Anatomy. All cavities of the body, right, like the heart, are lined by a serous membrane, which you remember from 241 is really simple squamous epithelium. We have various names for serous membranes depending upon where Superman finds them. Nice outfit, by the way. All right? So if they're in the lungs, it's pleura. And the same basic idea, right? We have the lining that covers the chamber the organ sits in, and then we have the lining actually on the organ itself. We have a parietal layer and a visceral layer. All cavities have this. So, for example, if you look at the lungs, they're in the pleural cavity. The serous membrane lining the pleural cavity is the parietal pleura. And we realize the parietal pleura actually connects to the diaphragm. And then it comes up and folds in on itself and ends up actually now covering the lungs themselves. It's really attached to the lungs. This will be then the viscera pleura. And we can see the magnified view of that up here, the parietal, the visceral, and then the actual space filled with fluid. And don't forget that that fluid comes from the serous membrane itself. Those cells, like ependymal cells, make cerebrospinal fluid. These cells are making this fluid. So it's a nice lubricated sac. On Monday, I'll have access for you guys to have, and I will encourage you to put on gloves, and you're going to pick up and hold sheep lung in your hand, right? And if you're actually holding the lung, you're actually touching the visceral pleura. I want you to feel how light and airy and fluffy lungs are. It's like meringue pie, right? It's really fluffy, full of little teeny microscopic air sacs. All right. Well, you guys have two lungs, the right and the left. The right is divided into 3 lobes. The left is divided into 2 lobes. How do we separate lobes? We use fissures. Like the longitudinal fissure in the brain separated the hemispheres, we can use fissures to separate lobes. You have 3 lobes on the right, 2 on the left. You have 2 different fissures to worry about for the right side. This one goes horizontally, so let's call it a horizontal fissure. This one goes obliquely, so let's call it the oblique fissure. And over here, we have another oblique. We have no horizontal. So that's easy. You got 5 lobes. You got 2 lungs. Total of 3 fissures. One of the reasons that we don't have 3 lobes over here is the heart got in the way. And there's literally a notch in that left lung where the heart would actually be. So if somebody had a brilliant epiphany, let's call it the cardiac notch in that. Well, what do you name the lobes? Well, it's pretty straightforward. If I have a top and bottom lobe, let's call one superior and the other one inferior. And if I've got 3 and there's one in the middle, let's call the one in the middle lobe, right? No fancy names, very straightforward. But you are going to want to practice them just so you don't panic and freak out. But this does take us to your favorite topic, organization, categorizing information. So there's 2 ways to think about your respiratory system. An upper and lower respiratory system, because you guys may have experienced or heard of someone having an upper or lower respiratory infection. That's because it's the upper part or the lower part that has the pathogen. Well, what part constitutes the upper respiratory tract? You go, I have no idea, John. Well, look at the diagram and I can see the brackets. And the brackets come all the way across and go, oh, it must be the larynx, pharynx, nasal cavity, and nose. And that means the lower respiratory tract must be comprised of the trachea, the bronchus, bronchioles, and terminals, and such. Right? So it shows you exactly what makes up the upper and the lower. But even more physiologically important is this idea over here. What's called the conducting system. These air ducts up here, right, are conducting air throughout your home, throughout the building. No heat or no cold air comes out of the duct, but it helps to transfer the air to different locations. That's the same thing as the conducting zone of your respiratory tract. There's no gas exchange here. No gas exchange. It is simply a way of getting the air from one place to another. And, well, where does my conducting zone end? Well, apparently it's something called the terminal bronchiole. And then everything below that is involved in the respiratory zone, which is where you could do gas exchange. You guys know it as external respiration. All right? Well, let's look at some of the epithelium, your all's favorite topic. Because you have two types of tissues listed on your need-to-know list, the very top. One's hyaline cartilage, the other is pseudostratified ciliated columnar epithelium. Well, what part of your respiratory system is comprised of pseudostratified ciliated columnar? Well, let's see. Nasal cavity, sinuses, something called the nasopharynx, the trachea, the larynx, main bronchi, and whatever lobar bronchi are, which you'll learn about in a minute. So basically, from your nose to the lobes, it's all lined with pseudostratified ciliated columnar. Except one little part in the back of the mouth, which we'll address in a moment. Now, there is sections that are comprised of ciliated columnar and ciliated cuboidal. That's nice. I don't care. Don't tell anybody, though. I don't care. But I do care about the top and the bottom one down here. Simple squamous, because that's what makes the wall of your alveoli. That's what's making the lung tissue, in a sense. Just don't tell anybody that I don't care about columnar and cuboidals. You got enough to memorize as it is. All right. Well, let's look at some of the gross anatomy inside of your upper respiratory tract. This is what's known as an open face. And you guys, does that look familiar to any of you? You're just like, yeah, I can see one over here, dude. Right? These are open face models. So it's going to be pretty damn easy to learn what's on there or on here because it looks just like the same silly thing. Okay, your only worry is what on there do I have to learn? If it's got a red dot next to it, you need to know it. So let's look at the nasal cavity for a moment. You've got concha, and that should sound familiar from 241 in terms of your skull landmarks. But you gotta use a little common sense. Sometimes you guys go, wait, I can't find the superior. Or is this the inferior? Is this the middle? Which one is this, dude? So remember when you guys grab York over here and you look at it, right? And we'll just drive Celeste nuts here. We're just going to do this for a minute, right? You look at it this way, right? You guys remember what the name of this one is? Right where I'm sticking my probe, the very bottom one? You forgot your 241? Well, it's the very bottom one. What's the word for? What's the word for lowest?
Inferior.
Yeah, right. And when you look at and you see the next one right above it, right? The one right up in there. Well, what's the one right above the inferior?
Superior.
No,
middle.
what's the one right above?
Middle.
The middle. Right. So that can't be a superior because it's the one right above the inferior. Because you know there's three. That's the trick, right? Anna, you know there's three. So if I'm seeing the bottom one and the one above it, that must be the middle. So where in the hell is the superior? Well, it's way up in there. You just can't see it on York here. But look at the open face models. And this way, Jessica. Jessica. Celeste. And over here. Hello.
All right, hi.
All right. Which one is this? Which one's that? Who's that one right there? Oh, that's a superior. Right? It's just not that pronounced. And just since we're in Halloween and you guys love trivia, you know those carnies and circuses who can swallow swords? You know the guys that can take a nail and put it all the way back in their skull and go, oh my God, how the hell can you do that? They're simply following the lower shelf. All the way, there's nothing in the way. It's kind of cool. You shouldn't try it. It's a bit of a kind of a sensation. I tried it once.
You tried it once.
So you just got to go into the nasal bout and keep it angled down, and you can go and really freak your friends out, right? There's just nothing in the way. That's why it works so easily.
But those swords are huge.
Huh?
But those swords are so big.
Well, that's not the nose. That's not a sword swallow. That's a nail.
Oh, sorry. There was a sword.
All right. No, don't stick a sword in your nose. Oh my God, no, don't do that. All right. So now we have, all right, nasal cavities. Is there a red dot there? No. What does that mean then?
None.
Skip it, cool, all right? But your pharyngeal tonsils, because we kind of noticed those when we did the immune system, our little teeny crash course. Remember, tonsils are lymphoid tissue. It's a localized, concentrated region of B and T cells, your immune response. And it kind of makes sense to have at the back of your nose, because as you inhale, all the pathogens in your air might be then able to pass by and we can attack and kill the germs that are there. But you also got two other ones, right? This is your palate. Let's call them a palatine tonsil. And what's this thing here? The tongue. And someone who studies speech or language, what are they called? Someone who studies language. A linguist.
No.
Lingual for tongue. So lingual tonsils are the tissues at the far back of the base of the tongue. As much as you can, let anatomy tell you where it's located, right? Palatine, palate, lingual, tongue, right? The pharyngeal is a horrible name. If they call it the nasopharyngeal, that'd be awesome, but they didn't. All right? Opening the auditory tubes, don't need to worry about that, right? Soft palate, uvula, no. But now we have the pharynx, and you want to practice spelling these words, right? Nasopharynx, oropharynx, laryngopharynx, right? First get that down. There's three of them. Then we got to worry about where the hell they are. So let's look at the lower border of the nasopharynx. That's what this blue line represents. And as you do it, and you say, John, I don't know where the hell that is. Well, look at it for a minute. What is this thing? Uvula. So that means that's the bottom. So if you find your uvula, go up. That has to be the nasopharyngeal region, right along through here. And in case that doesn't work for you, I gave you another way of looking at it. Right? So don't ever ask me where the nasopharyngeal region is, because right here, it shows you where it is, right? Right there, there's the nasopharyngeal. And then if I look at the uvula, right down to about where the hyoid bone is, right there. Right? That purplish area is the oropharynx, which we can see in the previous slide. Right? As there's the hyoid bone. So from here up to the uvula, right? All that area is the oropharynx, which kind of makes sense because that's where your mouth is. And someone who talks, what are they known as? A great speech giver is known as an orator. Yes, all right. Oropharynx, orator, oral, right? It's all in line with that. And then right below it, right just past the entrance to the esophagus, right along in here, right? That's a little teeny region of the laryngopharynx, right in there. So you want to figure out what can you use as the differentiating or the borders from naso to oro to laryngopharyngeal, right? Study this diagram and that one. Do you get an idea of where does it start and stop? And the important thing for this one is this is your trachea, and that's your esophagus. So my laryngopharynx is at the opening to the esophagus and the trachea. And there is a structure that we're going to be looking at in a second. If we come over here, you need to know where the esophagus is in relation to where the trachea is. And it's a habit of simply just looking and being literal. And I realized, what's this thing here, do you guys think? Spinal column, right? So the esophagus is right in front of the spinal column. And right in front of that is the trachea. So it's a 1, 2, 3. Have an idea. Now over here, we have the larynx, another red dot. 3 parts to it. So first memorize the 3 parts, right? Epiglottis, thyroid cartilage, and hypophyseal cartilage. But look at where the epiglottis is, right? It's this little bluish flap. Let me get the bars out of there for a second. It's this little flap right here. It's kind of thought of as a trap door, and it's coordinated with your medulla. Every time you swallow, you have to stop breathing, because who here can swallow and breathe at the same time? There's only one age group that can, and I'm really jealous. Babies, when they're nursing, they can both swallow and breathe at the same time, which means they can chug a lot of beer. Okay. But for us, we can't chug it. So what happens is this. Epiglottis folds down like a flap, just like this, to block the entrance to the trachea. So the food can only go down into the esophagus. But when you guys are in a hurry, or you try and laugh at the same time as swallowing something, right, things don't go well, right? Think about the next time you do have that unfortunate incident of swallowing just a little drop of something. I mean, it's a little teeny drop, but you're going to cough your head off for a couple of minutes because it's going down into the trachea, and the lungs say, get this the hell out of here. And so you cough and cough and cough and cough, trying to move that liquid up and get it out of the trachea. It's a very sensitive point. So that's how you guys can find the laryngopharynx. The opening to the esophagus, the opening to the trachea, right? And in that same region, we have the epiglottis, the thyroid cartilage, and the cricoid cartilage. Well, let's look at that larynx, aka voice box. There are three main cartilaginous structures I want you guys to know. We've already named them, right? Epiglottis, thyroid cartilage, and cricoid cartilage. The thyroid is, if you put your fingers on here, this is your Adam's apple. That is your thyroid cartilage. Now, without choking yourself to death, come down and try and find that little notch just inferior to the tip of your thyroid. That little notch is this thing right here. And that little band of cartilage is called the cricoid cartilage. And this is the target you guys used to have when you had to do an emergency tracheotomy. Someone who can't breathe and you just shove a pen in your throat. You're going right through here. There's no cartilage. It's just ligament that's easy to cut through. But that's the cricoid, that's the thyroid, that's epiglottis. And notice that these two are in red and that one's in purple. Because these two are made of hyaline cartilage. I want them firm, I want them rigid. But I want my epiglottis to be like a springboard. And what kind of cartilage is really springy? Elastic. So that's why it's a different color, because it's a different kind of cartilage. The epiglottis is made up of elastic cartilage. Maybe E for epiglottis, E for elastic. Those two are made of hyaline, and then don't tell anybody, but I could care less about the rest of it. They're too small, too hard, they don't have any good models for it, so why bother trying to memorize the idea of the racinoid cartilage, the corniculates, the cuneiform? They're important, but we don't have any good model to represent it, so why bother? All right, we're going for the big major structures. But now notice the front part here, your trachea, right? And look at the posterior side. Do those rings of cartilage go all the way around?
No.
No, they're referred to as C-shaped rings because they're in the shape of a C. And they don't go all the way around. They're still hyaline cartilage. But why don't they go all the way around? Because what is immediately behind the trachea? The esophagus, right? And if you guys have a large bolus of food, the esophagus has to expand. I need a place to bulge into. And so we have this place where it's a little more flexible back here. And when you guys look at those things, and people don't put models backward. Let me yell at the first one, just because it's fun to yell. No. Let's keep respiration with respiration stuff. I'm missing two more trachea. There's one way down here, which is kind of okay, but belongs more on this shelf. Remember how I always hound you guys about, where's your book? And then make it match the book. So if you get a model of a larynx, right, it looks a lot like this, right? Thyroid, cricoid, epiglottis, and I can even see my rings of cartilage here. And you can feel them off to the side. Palpate your windpipe, right? And you can actually go up and down and actually feel the little rib-like structures. And that's these rings of cartilage. And they're there to keep your trachea from collapsing every time you breathe in. If you didn't have them, this is what breathing is like. I have an entrance to my nose, and it goes into a closed-off system in your chest. So put a straw in your mouth and pinch this end and suck. Inhale. What happens to the straw? It collapses. Right? I don't want that happening to me. So this is a reinforcing structure to keep the trachea from collapsing every time you inhale. It's becoming more of a lost art. I used to be able to give this analogy when I was in graduate school, but if you ever work on engines and you have a radiator hose, right? A radiator hose has a metal coil inside the hose to keep the hose from collapsing every time the water pump works, to suck water in, otherwise the hose would collapse. But we're just taking biology and using it for mechanics. And that's why we have them. You get about 15 to 20 of them that go all the way down your trachea. Vocal folds. Don't call them vocal cords. They're vocal folds because they are a fold of tissue. These are what create your voice. And they're like a reed on a wind instrument, right? When you blow over the reed vibrates. When air passes by these vibrate, and that creates your sound. Helium makes them really taut, which is why you guys get a Mickey Mouse voice when you breathe helium. Because it makes this tissue elongate. Otherwise, everything else, any red dots? Nope, so don't worry about anything on there other than calling them vocal folds, not vocal cords. And they are responsible for making your voice, your vocalization. All right, let's look at your conducting system. And you practice. Now, there's my larynx, made of hyaline cartilage. There's my cricoid, made of hyaline cartilage. These are my C-shaped rings of cartilage, also made of hyaline. And then my trachea branches. And just like arteries, when they branch, you're going to change their names. This is the first branch. Another word for first is primary. So my first branch gives me my primary bronchi. You have a right and a left primary bronchi. Now you want to practice how you need to think about this. There's two ways to talk about this. I could say the trachea become what? Well, they become primaries. And then primaries will become secondaries. And secondaries will become tertiaries, blah, blah, blah. Or I could talk about what do they lead to. When you talk about what they lead to, that means what structure do they go to of the lung. Primaries go to the right and left lung. But primaries would become secondaries. Secondaries lead to lobes. That's why some books call them lobar bronchi, because they go to the lobes. And you pause for a minute. Does anybody remember how many lobes we have on the right-hand side?
3.
We've got 3. So how many secondary bronchi should we have?
3.
We should have 3 because each one goes to the lobe. How many lobes on the left?
2.
So how many secondaries should we have? We should have 2, right? You have 2 secondaries and 3 secondaries on the right. Now we have these rings of cartilage from the trachea down to the primaries. The secondaries also have rings of cartilage. Here's a cross-section of your trachea. There's the esophagus posterior to the trachea we have over here. Right? Remember, lumen means the hole, the passageway. And there's this red stuff. Right? Remember, what is the definition of epithelium? Do you guys remember?
Something.
It's what, Anna?
Something that lines the inside or outside.
Exactly, right? The tissue that lines the inside or outside of a structure. So is this epithelia?
Mm-hmm.
Yeah, right? Is this side of my feet epithelia?
Yes.
I haven't put my finger's been touching this table. All right? The lining of my trachea? Epithelia. Well, what kind of epithelia? Pseudostratified. Right? Remember, that's a type of epithelia. Remember, you name epithelia based on the number of layers and the shape of the cells at the topmost layer. Right? So all of this, that thin little red line where it says respiratory epithelium, that is your pseudostratified ciliated. This orange yellowish thing is a band of hyaline cartilage. It's here to show you that it is a C-shaped structure. It doesn't go all the way around. Ooh, you have a common carotid right there. And if you remember, it's parallel to the trachea. That's nice, John. Okay. Now, this is about ciliated tissues, not so much about really columnar or pseudostratified, because no one is giving me a pseudostratified, which I really wanted, but they don't really do that. So regardless, even though this is columnar and that it's ciliated, you can also think of this as pseudostratified. All right? Any tissue in the respiratory tract that has cilia is going to be covered with mucus. Right? And that's this stuff right here. The brown things are particles of dirt, debris. that were in the air that are now in the mucus, because the mucus acts like flypaper. It's there to clean the air as it passes over it so you don't get dirt in your alveoli. You don't want dirt in your alveoli. If you've ever been in a really good dust storm and blown your nose, right, you get a lot of dirt out of your nose because that's the dirt stuck in the mucus. Or if you've coughed up after a dust storm or a windstorm, right, you're coughing up the dirt that was going down the trachea, probably into the primaries, even into the secondaries, even into the tertiaries. But as you go further down, there's less and less dirt because most of it's being stuck to the mucus. Well, do you guys ever have to change your air filter in your car? Have to change the filter to your heating system? Yeah, you should, right? And if you have a new modern car like mine, I have a HEPA filter in my cabin of my car, so I have clean air in the cabin. You got to change those out because why? They collect dirt. When you guys get dirt in the mucus, the cilia have a beating fashion, and they literally beat in an upwards direction to bring the mucus up to your laryngopharynx. For you to cough it up and then do one of two things: swallow or spit. Right? But that's how you get rid of the dirty mucus that's in there. Well, what if the cilia can't beat? Well, then how are you going to get the mucus out? Right? That's a problem.
What about when we take cough suppressant? I mean, is that...
Oh, we'll get that. Hold it.
Okay.
So, cilia help to move. It's called the escalator effect. Because you're kind of like moving like an escalator up. Chronic, long-term, heavy smokers. Well, what's a chronic? What is heavy? It's kind of an argument. But the idea is that if you smoke a lot for a long time, the smoke kills the cilia.
Yeah.
Smoke kills cilia. Any smoke would kill cilia. So if you smoke leaves from a maple tree, that's smoke. Marijuana, that's smoke. Cigarettes, that's smoke. Right? And it'll kill the cilia. And you may sort of thought about, you know, that old saying of a smoker's hack, right? Think of the kind of a cough a chronic old smoker has to do, right? It's a forceful, hard cough because they no longer have the cilia. They must have a forceful movement of air and shake the thoracic cavity to shake the mucus loose. And they tend to create a much larger bolus of mucus. Because you and I, we're constantly doing this. If you can, put a thought in the side of your head, not the back of your head, but either your friend or yourself, whenever you kind of go, that's you taking that mucus that just got brought up and swallowing it. It's just glycoproteins and carbohydrates and some dirt, right? But you're doing it very subconsciously, unless you have a really bad upper respiratory cough where you're coughing all the time. Now, cough suppressants are interesting. I've been taking a lot of them lately, Dyson. And what it does is it goes to the medulla and tells the medulla to stop sending signals to the muscles that contract to cause me to cough. If you think about what a cough is, like a spasm. So it's a quick contraction of the diaphragm, but it's also forced, right? So you're going to be using scalenes and pectoralis muscles. It's also a forced exhalation, so abdominal muscles. How many of you ever had a really bad long cough and you got like beat up in the ribs, right? You're really sore. Because all these muscles are, yeah, I had that about 3 weeks ago, right? And the cough suppressant stops that, so you are going to get a bit of buildup in the mucus. But most cough syrups add something else. Anybody know what it is? The layman's, not the pharmaceutical name. An expectorant to help loosen the stuff so it'll come out a little easier. And they also tell you to drink lots of liquids, right? To keep the mucus as thin and as watery as possible. And there's like I said, there's a bit of a problem. You don't want to cough, so I'm going to give you cough suppressant, but you need to cough to get rid of the mucus. Like fevers, right? You give little kiddos aspirin or Tylenol for a fever. You take aspirin for a fever. But the fever's there to help kill the germs. So you're taking aspirin to turn off the fever. Your body going, I just made this heat, damn it. I'm trying to kill the bugs. You want me to cool off? Fine. So there's always a give and take to medicines that we do. But the idea is this, right? Ciliated cells normally, naturally need to move the mucus up because it contains all the trapped debris that normally is in the air, that goes into your lungs, and you always expel it, usually in a very subconscious fashion. Smoking, however, will, for chronic, long-term, whatever that is, right, will help kill that.
But it won't grow back?
Well, it kind of depends. Like my father back in the 60s was a 2-pack-a-day Camel smoker. All right, no filters, hardcore. And we used to collect Raleigh stamps when I was a little kid. He stopped in 1967, 1968. Hasn't smoked since. And he's got the lungs of a 50-year-old. He's 91 right now. So he stopped probably early enough on that he wasn't that damaged. These cells will repair themselves to an extent. And if you damage the stem cells, then no mitotic division will help you replace the damaged ones that are there. Let's go back to your conducting system. So, Anna?
Going back to the mucus catching dirt, does it catch pathogens and things like that?
Anything that sticks to it, yeah. So you can get virons, you can get virus particles, you can get bacteria.
So those aren't too small?
No, I mean, if you think about it, a wad of mucus is like gigantic to a bacteria cell. So you'll get sucked pretty quickly, but we're also talking about, tens of millions per cubic milliliter. So there's a lot of viruses. And so if you're in the middle of to get to your answer, if this is a cross-section of my trachea, and I'm looking at the lining of mucus in my trachea, just sort of like this. And then we look at what we really have is all the white spots here, right, is the air flow. The air closest to the mucus has a much better chance of coming in contact, but in the center, the air flows faster. It's called laminar flow. Anything by the wall of a structure, even for blood vessels, the blood next to the wall of a blood vessel travels slower than the blood in the center of a blood vessel, because there's least resistance. So those viruses probably go right into your lungs, all the way to the very bottom. These guys, though, will get stuck because they're being turbulated around, and they're bouncing around and getting stuck to the mucus. It'd be nice if we could have 100% pure way of doing that, but we need a much longer respiratory pathway to do it. All right, so now we're on to the rest of our respiratory tract. So you practice for a minute. Trachea, right? Right primary, left primary, 1 secondary, 2 secondary, so they have 1, 2 lobes. But then secondaries then will become tertiaries. Well, tertiaries lead to what's called a bronchopulmonary segment. And great, thanks, more things to learn. All right, so let's review that for a second. What do primary bronchi lead to? Primaries lead to lungs, right? Secondaries lead to lobes, and tertiaries lead to what are called bronchopulmonary segments, little individual compartments that you're not going to really see in a model.